All right, welcome to the gpMLBot demo. I'm going to try to make this a little bit brief just to capture your attention. And so what we're going to do today is a credit card fraud detection demo. And really our goals of this is to have detect credit card fraud in real time without needing a data scientist. And what we're going to do, hopefully, is deploy a machine learning algorithm to an actual production data pipeline today, again, with minimal need of a data scientist. So how can we get results today and get some value added in a sense without jumping through a bunch of hoops and making it kind of easy? So that's what I want to show. And just to kind of set the stage is we're going to have to start with a data set to train our model. And what we have is an input table data set of 2 days of credit card transactions, where 492 are fraudulent transactions out of 284,000. And we need to have some as marked as fraudulent so that our model can learn from it, essentially. And what this data has is it's going to have these fields called V1, V2, V3, up to V28 fields, which we call features. And those features are going to be things like the merchant of the credit card transaction, the purchase location, the purchase category of the credit card transaction, things like that. Just know that they've been transformed into these V1, V2, V3 due to confidentiality. And that's a little bit outside our control from where we got this data set from. So just know that these V1, V2 are actual fields in real life. And then just to kind of give a quick overview of what we're doing today is gpMLBot has 3 main commands or phases. The first one is train. So we're going to run the training command. And what this really does is it trains a model that's going to run a bunch of algorithms. And from all these algorithms, it's going to detect the best one for our particular data set. And it's going to save that best algorithm as a trained model for us to use later on. And part of this training process is gpMLBot will identify and remove these correlated features automatically to speed up algorithms. So for example, if V1 and V2 are correlated with one another, we can eliminate one of those to simplify. And it's going to do that under the hood, and we'll show you that. And then the next phase is predict, where predict is we basically take their trained model, run it against a brand new data set to forecast new values for us to verify our model. So again, predict is verifying our model on a new data set for us. And the last thing is deploy. So deploy allows us to export our trained model and plug it into our streaming data pipeline in order to do real-time fraud detection in our end-to-end data pipeline. All right. So we're going to jump to our command line and actually run our product. And so we run gpMLBot, and we're going to pass it the Greenplum location. So the Greenplum home directory and the Greenplum port, and then whatever user we're running as. And so this is just kind of the intro screen that shows you all the commands and how we're going to walk through, which I just explained. And the first thing is you're going to click left and right to navigate between the screens, left and right arrows. And the first question to ask you is, what database do you want to connect to? Like, where's your table, our training table? So these are all your databases, and you can click up and down. And we're going to hit enter and select the dev database. And then we come installed with some data sets. So in this case, we have credit card fraud data set, but just no available, which we can go into later. We have a forest fire demo set data set that detects area burn. We have predictive machine maintenance when the machine will fail data set. So we're going to do our credit card fraud. And the first question is, what's your ID column? And so this gives you a little preview of the table we're dealing with so that, for your help. And then down here, we have some help text if you need explanation on what we're asking about or more detail. And so for now, we're just going to choose the ID column, hit enter, go to the next screen. The screens look quite familiar, but do know that we're asking what's the column to predict on. Basically, it's the next question. And in this case, we're going to type classification or class to filter, and it'll automatically filter our results, as you can kind of see. I'm going to hit enter. And so what classification is, just a quick little explanation, is it's basically 0 if this row or credit card transaction was fraud, and 1 if it was fraudulent. So basically 0 non-fraudulent, or 1 is fraudulent, 0 not. And it's like classifying those transactions for us. And this is so that our credit card, our algorithm can learn from that and be trained. Feature columns. So this is kind of what I was explaining before, all these things. So we're going to choose a few of these. I know there's V through 128, but just to kind of keep things simple for now or speed things up. And again, these are things like merchant, price, location, purchase category, amount, things of that sort. Grouping column, we're not going to have a grouping column. And all to run, we're going to choose a classification. Classification is basically if something's kind of like yes or no, or is it fraud or not kind of thing. And regression type of problem is if we want to predict an actual value, like how much fraud, like the actual amount, or an actual value, or how much area burned in this forest fire, where classification is kind of a yes or no. It's a little more detailed than that, but that's the main idea. Next are all the various algorithms that we can choose from and run. So just know that we come pre-selected with all, and then if you hit enter, you can kind of unselect those. So we're going to keep them all selected to run all those algorithms. You can run another table and train on another input if you do, but in this case we don't. So this is that feature summary thing. So we put in this number of features, but we found that these ones are correlated. So V7 is correlated to V2. Over here, for example, V4 is correlated to V3, etc. So what we can do is simplify our input to just this. So we started with this amount of input, and we can kind of simplify to this since we, under the hood, found out which ones are correlated. Just kind of keeps things fast and speeds up the calculations, things like that. So if we go to the next screen, we can actually run our algorithm. It's in real time. So up here, it kind of keeps a track of 0 to 6 algorithms completed. And you can kind of see them pop up as they go in real time. Over here, we have like the duration, the accuracy and precision, and we're automatically ranking them, which is the best algorithm and the worst for us based on this accuracy and precision. When the results are done, it says, hey, check out this results file, which I can kind of take a quick look at. So again, this results file basically has the config used. So the config parameters entered. And let me just show you a quick, so kind of like you can use this config file of everything that we just entered. So if you want to repeat the run or have a reliable way of rerunning things, just use that config file next time. Again, we give that recorded values of our feature summaries, which I did before. We show our results just like before. So everything's recorded in this file for you to go back to. The last thing, which is quite cool, is we show you the actual SQL that was used to run. So this SQL here is basically exactly what we ran under the hood to do PostgreSQLite gpM, for example, or XGBoost. So if you're a kind of advanced user or want a quick way of learning how to use these tools, you can run gpMLBot, tweak the SQL to your heart's desire, see what we're running, kind of copy and paste it, expand it, edit it, and kind of run off on your own. And so this is kind of a way to jumpstart you if you want, or see what's actually being run, or things like that. So that's quite helpful. So this was the training phase. So we created a model. Now we're going to go on to predict. And it says, would you like to proceed with predict? Which predict basically takes your trained model and runs it on a brand new data set to verify it. So we're going to choose a new data set. In this case, we're going to connect to the dev database. And our new data set to verify things and forecast new values is this predict table. And what's the ID column on this predict table? Same thing. And here's where we look at the previous models that are trained. So we can see, hey, what models are we trying to train and run against this new data set? As you can see, there's two entries here for the same table. So we have two models that were trained on the same table. And one example of that is, hey, let's say new data came in between when you train the model. And so you're going to need to retrain your model if new data came in, potentially, depending on your use case. So just know that that's possible, or that's available. So we're going to choose this model that we trained, and we're going to run it against that data set that we just pointed to. And this is going to take a little while, potentially. That kind of depends on the size of your data set. So prediction completed. And as you can see, it gives the output table of the predicted results table. And what this is basically saying is 14,800 transactions were fraudulent in our data set, and about this many were not fraudulent that it found. Then it tells us a file where we record these results so we can look back on it again in the future. So if we take a quick peek at that table, we can see that it'll give us the ID column for our original table and then whether it was fraudulent or not. And so what we can do is we can join that with our original table to correlate the IDs together. And basically what this is telling us is, hey, this row or this transaction at this time for this amount and these feature column were fraudulent and these ones weren't. And so you can kind of look at it. So excellent. Now, if we move on to deploy, prediction is done. Would you like to deploy this trained model into our data pipeline or production pipeline? And so here's our trained models to select from. And so we're going to select this model to export, essentially. And there's two ways of exporting. We can export as SQL or non-SQL, where non-SQL is basically to be used in a Python or Java server application, where you can basically use your trained model in a Python or a Java environment. In this case, we're just going to show SQL for this demonstration purposes real quick. And basically what it outputs us is two files, one to load our trained model into our data pipeline, in this case, another database or our production database. And then two, where we need to maybe tweak and edit to prediction SQL, which actually runs the trained model. And so this is pretty straightforward. Let's take a quick little peek. And these are the copy statements where we load our trained model into our production database. So pretty straightforward. And these are to get the model, you need to run all those. And then here's how we actually, after loading our trained model up above, this is how we call it or execute it. And we need to just tweak a few values right here, replace the dollar variable. So as you can see right here, select pgml predict on this output table with these features from your input table. And that's basically how you call your model that you've loaded up above. And this you can put into your real life data pipeline and start getting some value added today.